Let's start with a simple example. Inspecting a built-in type, like string. So let's add one here, string name equals Kevin. If we have an instance of that, we can use the getType method. So we store the type of our name field in a variable named string type. To get to that, we call into getType on our name variable. Let's drill into this by going to the definition. And what we see here is that this is implemented on the object class, the base class for all objects in C#. That means that we can call getType on each class instance you have access to. As we can read, what it returns is a system.type. Let's have a look at that. So we go to the definition of system.type, and we see that it is an abstract class, deriving from member info. More on that later. It contains quite a few properties that all give us info about this type, like whether it's a class or an array, or even whether it has generic type parameters. Next to that, it also contains a bunch of methods that we can execute on it. We can get its constructors, for example. We can ask for the potential interfaces the type adheres to, and so on. We'll encounter quite a few of these throughout the course. For now, just remember that the type class represents type declarations, like class types, interface types, array types, type parameters, and so on. Alright, back to our program class, and let's write this out. So, let's execute a console.writeLine statement, passing through string type. And let me add a readline statement as well. And let's set a breakpoint here, right before the writeLine statement, so we can effectively inspect the type. Alright, let's build and run. We hit our breakpoint. And if we look at what is in there, we see a lot of information related to the string type. We can see the full name. We can see fields that are declared on it, like the string length. And if we scroll down a bit more, we can see that it is not an abstract class, it is not an array, but it is a class, and so on and so on. So there's a lot of information here you can find out about a string, and it relates to the fields we saw when we looked at the definition of system.type. All right, let's continue. And we see that what is effectively written out is the name, system.string. Okay, so this is great when you have an instance, name in our case. But what if you don't have that? Let me close this. Well, in case you don't have an instance of a string, like our name field here, you can still get to the type via the typeOf operator. Let me comment this out so you still have it for reference. And to get to the string type, we type typeOf and we pass through string. We still write out result. Let's have a look at what this gives. And there we go, the same result. Interesting as this may be, you're often more interested in non-built-in types. So let's add a few so we can inspect them. Let me add a new class to our reflection sample project. I'll name it Demo Classes. And let me paste in some code here. We'll immediately inspect it. And there we go. The first thing that is defined is an interface, a public interface, iTalk, which requires implementing classes to have at least one method, talk, returning void. I also defined an attribute, employee marker attribute. We've got an employee here marked with that attribute, which derives from person. If we peek at the definition of person, we see that it implements iTalk and exposes a few fields. We'll encounter it immediately, but what we also see is that an employee next to the fields on person, has one additional field, company. We've also got a class here, alien, that implements the iTalk interface. And then, of course, we got that person class. It also implements the iTalk interface. That means it has a method talk. But next to that, it also has a few other things. It has a public field, age, and a private field. It also has a public property, name. We will use all of these during the course. On top of that, there's two constructors that are public, one that doesn't accept any parameters, and one that accepts a name and uses that to set the name property. And then there's also one private constructor. That one accepts two parameters, name and age, and sets them as well. As it implements the iTalk interface, and as we just looked into, the talk method is here, but next to that, it also has a yell method. That is exactly the same as the talk method, only a bit louder. Lastly, I added an override for the toString method, so we can easily know about which person we're talking when writing it out. Alright, that's it for a few of the demo classes we will use during the course. Let's write out some info about these types. So let's switch back to the program class. I'll comment out our old code, but I'll leave it here for reference. And there we go. So we want to write out some info about these types. And we know where these types reside, in the current assembly, because we've just coded them in there. So what we can do to get to these types is start from the assembly. For that, we call into the assembly classes getExecutingAssembly method. Assembly is defined in system.reflection, so let's add a using statement. The assembly class represents an assembly, and getExecutingAssembly then gets the assembly that contains the code that is currently executing. Once we have the current assembly, we can call getTypes on it, which will return all the types defined in this assembly. And once we have those, we can run through all of them and write out their names. There we go. That should do the trick. Let's give that a try. And what we see here are a few built-in classes, automatically included in the console app template, like the program class. But we also find the types we defined ourselves, like the iTalk interface, the employee marker attribute, or the employee, alien, and person classes. Now, these are not the only ways to get information about a type. In fact, let's think back at the assembly module type hierarchy and start with assembly. We already know how to get to the current assembly and get all types from it. If we want to get just one type, we call getType on current assembly, passing through the type name. Note that this must be the fully qualified type name, so with the namespace included. Let me put a breakpoint here and let's give that a try so we can have a look. There we go. Our one type from current assembly is the person type as expected. This code works. But types might also be defined in external assemblies that are not loaded yet. For example, system.text.json. System.text.json is one of Microsoft's relatively new assemblies that contains information on how to work with JSON. It's typically used when creating APIs. But for a console app, it is not loaded by default. So we need to manually load it. So as far as the console app is concerned, it is an external assembly that hasn't been loaded yet. So to get to that, we need to load it. And we do that by calling load on assembly, passing through the name. Once we've got that external assembly, we can again get all types from it by calling into getTypes, or one specific type by calling into getType. JSON property, for example, is a very typical, commonly used type from system.text.json. Let's have a look at what gives. We hit our breakpoint. If we look at types from external assembly, we see that 283 types have been loaded. And if we try to get one type from the assembly, we see that we indeed got our JSON property type. So, like that, you can load types from external assemblies. Next in the hierarchy, right underneath the assembly, were the modules. We can get to those by calling getModule or getModules on an assembly. For example, by calling getModules on our external assembly, we should get a list of the included modules in system.text.json. We can also try getting one specific module, and the syntax is much like trying to get one specific type. Instead of calling getType on our external assembly, passing through the fully qualified type name, we call getModule on our assembly, passing through the fully qualified module name. In our case, that's system.text.json.dll. Let's give this a try. We hit our breakpoint. If we look at modules from external assembly, we see there's just one. As we learn on the slides, in 99% of the time there's only one module in an assembly. The module was named system.text.json.dll, and that happens to be the one we manually loaded by calling getModule on the external assembly. So if we look at this, we see that it indeed contains that exact same module. All right. Once we have that, we can again ask for all types or one specific type from that module. We do that by calling getTypes on one module from external assembly, or we call getType and we pass through the fully qualified name. It makes sense that this is possible on assemblies, on modules, etc. Let's give this a try. And what we see is that 283 types are in this module, which of course matches the amount of types in the assembly itself because the assembly contained exactly one module. Obviously, one type from module from external assembly also contains our JSON property type as expected. So with that, you know about various ways to get types. There's a lot more we can do with types. Let's check that out in the next demo.